Hello, everybody. Good morning. So today is Friday, and my plan is we finish the chapter 7 review of the formula, and then we kind of look at the practice exam and see what type of problems on the practice exams, and then we go over your quiz. So your quiz 1, mistake and the solution. Today you have homework 7.4 is due. Remember, you gotta submit your first attempt by midnight. So after the deadline, you can continue to work on your homework to improve your scores. Okay, everybody? All right. So yeah, what happened to other students? I hope they can count. Oh, yes. More students count better. Okay. All right, so let's see. Okay, let's continue with our formula sheets. Okay, do you still have this paper with you? Yes? Okay, so last time, the six trig function, so Kato, we fill in opposite, adjacent, and hypotenuse, right? And then we also fill with x, y, r. If the point is on the xy plane, we want to fill with x, y, r. And we also use this information to figure out whether the trig function is positive or negative in different quadrants. Right, everybody? And last time we also talked about the hexagon. And we have 3 diagonals. We get a diagonal formula. And we have 3 upside down triangles. Right? So we get a triangle formula. And then length of sector. S equals theta times R. The theta must be in radian. So last time we didn't put in radian. This time, mark it down. The theta must be in radian. Okay, so radian, how we define radian? It was the ratio of the length of the R over R. So radian is the ratio of length. Okay, but if you put degree there, it will be wrong. So make sure you convert the degree into radian. Is that okay, everybody? Mm-hmm. And remember, pi equals how many degrees? 180. Okay, so that is how you convert degree to radian. So we can write it down. Pi is 180 degree. Use this to convert. And also area of sector. 1/2 theta r squared. The theta must be in radian as well. So actually, if you see the real life problems in all of these computations, the theta, the angle, must be in radian. And last time we talked about the angular speed. It's actually theta over t, but if the problem give you like 6 revolutions per minute, then you know 1 revolution is 2 pi. So you compute the angle in radian. Okay, everybody? But maybe the problem give you, 5 radian in 2 seconds. Then you use 5 radian over 2 seconds. You get what? 2.5 radian per second. So that is the angular speed. Is that okay, everybody? Mm-hmm. That's the angular speed. And then the linear speed equals the W times R. So we use the angular speed multiplied by the radius. So if the radius is bigger, the linear speed is bigger. Mm-hmm. Everybody finish this part? You still have this page? Mm-hmm. Okay. So in the exam, I will give you this blank formula sheet with the exam. So you can spend 1 minute or 2 minutes to fill it out. And then when you work on your exam, you just look at the formula here. Mm-hmm. Okay. Reference angle. So there are problems in the exam require you to find the reference angle. So please read the problem carefully. Because some problem, if I say round your answer to 3 decimal places, it means you can use your calculator. Okay? There are some problems that please find the exact value. exact value, you're not supposed to use your calculator. Is that clear, everybody? Okay, and you need to show all your work because some problems I give you 10 points. It's not just for one answer. The 10 point is really the full solution process is 10 points. Okay, it's not like your homework. You just enter the final answer. It really needs you to show all the work, how you derive to this answer, step by step. Okay. All right, so reference angle. We draw the picture, then we can find the reference angle. Right, so quadrant 1. Okay, so quadrant 1, we have x, y, and the origin. So let's say this is quadrant 1, and that's t. And then the reference angle is the angle made with the terminal side and the x-axis. Do you see here the reference angle is the same as the t? The reference angle t prime equals to t. That is in the first quadrant. So you draw the picture, then you can see. Okay. Quadrant 2. So my angle is in quadrant 2. And then the reference angle is the angle made with the terminal side and the x-axis. Therefore, the t prime, the reference angle is right here. So reference angle is always between 0 to 90 degrees. Okay? So it's always between 0 and 90 degrees. Okay, let's continue. Look at this picture. What's the relation between t and t prime? Yeah, we add them up. We get 180. So write it down. T plus t prime is 180 degrees. Therefore, if you want to find the t prime, it's 180 degrees minus t. Is that okay, everybody? That's quadrant 2. Quadrant 3. So you draw the angle t in quadrant 3. Then the reference angle is the angle made with the terminal side and the x-axis, which is right here. Right, everybody? That's t prime. And this whole thing is t. What's the relation between t and t prime? T minus 180, yes. So t prime is t minus 180 degrees. We can see that from the picture. Right, everybody? Okay, last one. Oops. Okay, so if t is right here, so that's t. And t prime, you see, t prime is right there. What's the relation between t and t prime? Yes. So when we add them together, we get 360 degrees, right? So t prime is 360 degrees minus t. Yes, everybody? But be careful, because sometimes if they give you t is a negative angle, like negative measure, for example, if they give you t is negative pi over 3, well, that means negative, you go what? Clockwise. So this is negative pi over 3. Yes, everybody, you go clockwise. So which means this angle is pi over 3. Okay, so the negative just means it goes clockwise. So in this case, the t is pi over 3. And you don't use like 2 pi minus the t. Is that okay, everybody? Attendance. Okay, thank you. All right. Any questions about the reference angle? After you find the reference angle, remember our trig of our function, our angle t is going to be plus or minus of the trig function. of the reference angle. Yes, everybody? Now the trig function of the reference angle, the values will be in our table. Yes, everybody? So the reference angle helps us to take care of any angle in any quadrant. Okay, from 0 to 2 pi. If the angle is outside of the range 0 and 2 pi, you add constant multiple of 2 pi or subtract multiple of 2 pi until you get the angle between 0 to 2 pi. Okay. Now, and this plus or minus depends on the trig function. Okay? Yeah, so you express the trig function in terms of x, y, r, and then you figure out in that quadrant the trig function is positive or negative. Okay? Yes. So if you miss some time, please watch the recording for the minutes you miss. So I want everybody to understand every problem in the exam. And I don't want, understand every problem we went over in class, like in the class worksheet and also your homework and the practice exams. If you have questions, please feel free to come to ask me. Okay? All right, so let's practice filling out this table again. So in terms of degree, so 0 is 0 degree. What is pi over 6? 30 degree, pi over 4, 45, pi over 3, 60 degree, and pi over 2, 90 degree. Do you see the angle is increasing? And in terms of the radius, do you see the denominator is decreasing? Because you have a smaller denominator, then the fraction is bigger. Okay, how do we fill in the row of sine theta? Yeah, square root of n over 2. And we let the angles from 0, 1, 2, 3, 4. Thank you. So now you guys take turns to answer my questions. Okay, sine 0. 0. Sine pi over 6. 1/2. Madison, sine pi over 4. Yes. Sine pi over 3. So we plug in 0, we get 0, plug in 1, we get 1/2. Yes. So square root of 3 over 2. Good. Jeremy. Which is square root of 4 over 2, which is, what's square root of 4? 2. What's 2 over 2? 1. Yes. That is 1. Okay. So remember those 5 numbers. 0, 1/2, root 2 over 2, root 3 over 2, and 1. Do you see the number is increasing? Yeah, the number is getting bigger, 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 bigger. That is the sign. Okay, how about cosine? Yeah, reverse the order, same number, right? So same number, but we reverse the order. Okay, so Sophie, cosine 0, 1. Emily, root 3 over 2. And Oscar? Yes. Let me know. 1/2. Guan? Yes. Right, everybody? So we find the pattern, and then we can figure it out, right? And then tangent. What is tangent? Yes, sine theta over cosine theta. Okay. Yes, so 0 over 1 is 0. And then Michael. 1 over root 3. Yes, so 1/2 over root 3 over 2 is 1 over root 3. We are using the first row divided by the second row. Yes, everybody? Okay, Joe. What is the next number? Yes. So square root of 2 over 2 over square root of 2 over 2. What is that? Yeah, that's 1. Good. Oh, 0 again? Yes. The square root of 3 over 2 over 1/2. The 2 cancel. We get root 3. And then next one. Undefined. Good. 1 over 0 is undefined. Okay, now cotangent. Medicine? Undefined. Square root of 3. Jeremy? What is cotangent? Pi over 4? Oh, sure. So we have the tangent. Use the first row over the second row.
I'm still on the last one. Sorry.
Oh, okay. Oh, okay. So please. 1. And Emily? 1 over root 3. And then Oscar?
0.
Yes. How about secant? What is secant?
1 over cosine.
Yeah, 1 over cosine. Okay, good. Can we know what is secant 0? Yes. So cosine is the second row. 1 over 1. So it's 1. 1. Yes, which is? You put the numerator and denominator. What do you get? Yes, you can leave it like that. I don't require you to rationalize your denominator, so you can just leave it like that. Okay, next. Yes, 1 over root 2 over 2 is 2 over root 2, which is root 2. Okay, everybody? Michael? Yes, 1 over 1/2 is 2. Joe? Second row, right? 1 over 0. What is that? 1 over 0 is undefined. We cannot have 0 in the denominator. Okay, everybody? Okay, cosecant. Cosecant. Yes. But the numbers, we can look at the secant and reverse the order. So we get undefined, then 2, then oh, so the next one? See?
2.
This goes here, and this is
2 over square root of 2.
yeah, which is square root of 2.
Me too.
Zach?
2 over square root.
Yes. Jeremy?
1.
Yes. Okay. So this is the formula we need for chapter 7. So everybody know how we derive all these numbers? Yes. So next class, I'm gonna give you a blank worksheet, and you will fill those out. Is that clear, everybody? And yeah, I hope all of you get them right. If you don't get them right, come to my office and do it again. By the way, on Wednesday, I give you back the unit circle worksheet, right? I said only 7 of you get them all correct, and then the other people, please come to my office to take it. And only 1 student come to my office and took it and get them all right. So how about the other 10 students? So please come to my office. Today, my office hour is from 11 to 1:50 and 3:10 to 4:30. You know, every day we learn something. We learn more and more stuff. Like this weekend, you need to remember this. Okay? So please don't wait. It's very easy to fall behind. I really want to help everybody to do well in this course. So please follow me. Sometimes I need to push you, but it's for your good. Okay? Yes. So
For the past, will we get a blank unit
yes,
circle?
not quite. You just get that because if you get this numbers, the unit circle is the numbers right here. Yeah. Okay, right. So any questions? No? All good? Okay. So yes. So next class. I will give you a blank worksheet to fill those out. So practice this at home over the weekend. And also do the practice exams. So where is the practice exam? On our course website and at the bottom of our course website. This is the practice exam. And this is practice exam 1 and the solution. So you need to what? Do the practice exam with pencil, and after you finish, you look at the solution and use red pen to grade your work. And check your answer step by step. Sometimes you might get the right answer, but did you show all the work? Okay, if some work is missing, fill those in. Okay, because when you look at the solution, so this is what the solution look like. I give you points. Like here you get 1 point, here you get another 2 points. Okay, so every step I give you the point. Like here, this problem is 7 points. You get these 3 points. You get this, then you get 6 points, and then you get the final answer is 7 points. So now don't just give me the final answer. If you just give me the final answer, what? You may just get 1 or 2 points out of 7 points. Is that clear, everybody? So I give you the solution with detailed solution and how many points in each step. So I really want you to make sure you understand the requirements. Okay? So problem 1, you're gonna convert the angles from degree to radian, or convert from radian to degrees. You know pi is how many degrees? 180. Yes. So okay, and give exact value. Okay, so give me a fraction. Do not use a decimal. Okay. All right. Number 2, find the angle with the measure between 0 and 360 degrees that is coterminal to the angle with the measure this. So this angle is outside of this range. You're gonna keep adding 360 degrees until you get an answer within this range. Yes, everybody? How about here? This is also outside of this range. So you keep, because it's positive, it's bigger than 2 pi, so you keep subtracting 2 pi until you get an angle that is within this range. Is that okay, everybody? All right, how about here? So your calculator only has sine, cosine, tangent. Cotangent is 1 over tangent. Cosecant is 1 over sine. Secant is 1 over cosine. So use that to compute. And then this problem, we learn about the reference angle. See, read the problem carefully. You need to draw the picture and figure out the reference angle. Yes? And then depends on the quadrant, your sine of negative 45 degrees is going to be plus or minus sine of the reference angle, 45 degrees, right? And plus or minus, look at the picture in terms of x, y, r, and then your sine is positive or negative. Is that clear, everybody? So you find the sine and you find the tangent. At the end, you multiply them. Here you find the secant, you find the cotangent, and then you multiply. You add them. Okay, everybody? So show all your work. This is like 3 steps. That's why it has 7 points. I expect you to show a lot of work. Okay, this one is the negative angles. Who are hungry and eat the negative sign? There are 6 trig functions. Sine, cosine, tangent, cotangent, secant, cosecant.
Is that just cosine like this?
cosine and secant. Remember cosine, secant is reciprocal of cosine. So cosine and secant, they're so hungry. They eat the minus sign. Okay, everybody? So remember that. Okay, so this one is like your quiz, right? You look at the X, I look at the Y, and then you can find the R. What is your X? Yes. What's your Y? 23. And what is R? Square root of X squared plus Y squared. Yes, everybody? Okay. If you miss some class, make sure you watch the recording to catch up. Okay? When is our exam? Next Monday. No, 2 Mondays. Yes, right there. Okay. All right. This one you need to draw the picture, right? And then figure out the cosecant is in terms of x, y, r, and then you let the x or let the y or let the r equals those numbers and find the other one. Okay, so this one is the angular speed and linear speed. You use what? The formula, right? You use these formula. Angular speed, linear speed. Okay, and then this one is what? Find the area. So area of the sector. Yes, 1/2 beta r squared. This one is what? You solve the right triangle. Remember your quiz? Yeah, we will go over your quiz. So this is similar to your quiz. Okay, you know 2 angles, because one of them is 90 degrees. And you know one side, and then you can find the other side. And this is also similar. But here, this triangle is not a right triangle. But you can put a line there, so you get 2 right triangles. Then your x is going to be this part plus this part. Is that okay? So that is your practice exam. Okay, so do the practice exam, and next week, questions.
Is the homework for this week the same stuff as the next?
Yes, your exam covers chapter 7.
What about the homework?
Oh, homework for next week is not in your exam. So, okay, but you don't have homework next week. So your homework 7.4 is due tonight, and then the weekend you can work on your practice exams. And then next week I will have time, like each day I ask you, do you have any question on the practice exam or your homework? You can print screen, show it to me, and then we can go over that. Okay. In the meanwhile, we also talk about section 8.1, and then your exam is on the Monday. Okay, so you have 1 week to study for the exam and catch up. Okay, so watch the recording, catch up, and practice the unit circle, and also practice this blank formula sheet. Okay, everybody? Okay, so if you can't forget about the pattern, like how to fill out those numbers, feel free to come to my office. I'm happy to go over the pattern with you to help you to understand it and be able to memorize them. Okay, so let's see. Cancel. Let me save it and then save as a PDF. Okay. So this sheet is also on our website. You see this formula sheet, chapter 7 blank, and with the answers. That's the one we just went over. And the unit circle blank and with answers. Okay, so 8.1, graphs of the sine and cosine function. So in chapter 7, we introduced the 6 trig functions. And we have the angle is the input, and the output is the ratio of 2 sides of a triangle, right? That's the input and output. And then in section 8, so chapter 8, we're going to talk about the graph of all the 6 trig functions. Okay, everybody? Okay, first, let's talk about a periodic function. A periodic function is a function such that f of x equals f of x plus np. Okay, so for every real number x in the domain of f, every integer n, so n is an integer, and some positive real numbers p. Okay, so periodic function, the graph repeats after p values. Okay, the p is called the period of the function. And all the 6 trig functions, they are periodic functions. Because look at your angle after 2 pi. It's kind of like the coterminal angles, right? It's kind of like the same angle. So you plug in the trig functions, you get the same numbers, right? So all the trig functions are periodic functions. And yeah, that's the unit circle. Now, how do we convert the values of the unit circle to the actual graph of sine x? Okay, we want to draw sine x. Well, it looks like there are a lot of numbers. I just want you to focus on 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, just focus on those 5 key points. Okay, what is sine 0? 0. Look at the table, right? You just filled out the table. Where is the table? Right here. And we're looking at sine 0 is 0, right? And sine pi over 2. What is sine pi over 2? 1. Okay, now we need the unit circle. Sine pi. What is sine pi? In the unit circle, remember we have x and y coordinate. The x is like cosine theta. Good. And the y coordinate is the sine theta. So sine theta, we're actually looking at the y coordinate. So sine 0 is 0. Sine pi over 2 is 1. Sine pi is 0. And sine 3 pi over 2 is -1. Good. So that one is 0. Then that is -1. How about 2 pi? 0. Is that okay, everybody? 5 key points. With the 5 key points, let's plot those on the xy plane. Okay, so x is 0, y is 0. Where is that? The origin. Everybody? The origin. Okay, so plot the origin. And then pi over 2. When x is pi over 2, the y is 1. Where's 1? Up there. Yes. Can you see from the picture? Pi over 2, 1. Next one. Pi, 0. Okay. And next one? 3 pi over 2, -1. And then 2 pi and 0. Everybody see those 5 key points? Now we connect the point smoothly. So we connect the point smoothly. Okay, so connect like this. By the way, you don't just connect like this, right? Don't just put like line segment to connect them. They should be very smooth. Okay, everybody? So with those 5 key points, we can draw the picture, right? The shape of the sine. So the sine function is like wave. Okay. And actually, you can see the unit circle, after 2 pi, you get the same values, right? So the sine function is a periodic function with the period is 2 pi. Okay, so therefore you can draw, you can continue. Okay, so kind of copy and paste. So it's gonna be here, here, and here, here. So copy and paste and connect them. So you get the graph of sine x. So far, so good, everybody? So to draw the graph of sine, just look at the 5 key points. Okay? 0 pi over 2 pi, 3 pi over 2, and the 2 pi. And the y value, 0, 1, 0, minus 1, 0. Is that okay, everybody? Now, if we go deeper, let's just focus on the first quadrant. If we go deeper, the first quadrant is right here. And what is sine pi over 6? 1/2. Good. What's sine pi over 4? Yes. What is sine pi over 3? 3 over 2. Yes. So, here, pi over 6 is here. So pi over 6 is here. And then, do you see 1/2 is here? Okay, when x is pi over 6, the y is 1/2. Where is pi over 4? That's pi over 2. Pi over 4 is the middle of pi over 2. Yes, everybody? So the middle, we can draw the middle here, pi over 4. And you get root 2 over 2. So maybe like here, this is root 2 over 2. Yes. And continue. Where is pi over 3? Yes, everybody? That is pi over 3. And the pi over 3 sine is root 3 over 2. Therefore, you see when the angle increases in the first quadrant, our y values increases. Okay? So just focus on the first quadrant because the other quadrant is going to be similar. Okay, if I ask you, oh, what is 2 pi over 3? By symmetry, you see the 2 pi over 3 is going to be the same as this point, the same height. Right, everybody? So you know that is root 3 over 2. If I ask you, okay, how about 3 pi over 4? Right here, do you see it's the same height as root 2 over 2? So all the other values, you can compare the first quadrant and use the reference angle to figure it out. All right, and look at the picture. What can you see? The quadrant 1. The quadrant 1, the sign is positive or negative? Positive. Quadrant 2. Positive. Yes. Quadrant 3. Negative. And quadrant 4? Negative. Yes. So the sign graph also can tell us those information. Okay, let's continue. So the period is 2 pi. And the graph is continuous over its entire domain. So continuous means you draw the graph without lifting the pencil from the paper. It's all okay. And the x-intercept. Where are the x-intercepts? We have here, that is 0. This is pi, 2 pi, minus 2 pi. So the x-intercept occurs at n pi, where n is a integer. Okay? N is an integer. Okay, also, do you remember last time I explained to you what is even function, what is odd function? Even function is like x squared is symmetric with respect to the y-axis. Odd function is like x cubed is symmetric with respect to the origin, right? Look at the graph of sine. It's symmetric with respect to the origin. Yes? So it's a odd function. So if you have the minus sign, you still have the minus sign. Remember we said cosine and secant are so hungry, they eat the minus sign, but all the other four trig functions, you still have the minus sign. Just put the minus sign in front. Okay, everybody? Mm-hmm. Good. And what is the domain and range? So here the domain. Oops. Okay. Yes. Our domain. It does not allow me to write. Interesting. Okay, now it's good. So domain is minus infinity to infinity. And the range. Yeah, very good. Minus 1 to 1. Right, everybody? Mm-hmm. Oh, it's on the top. Oh, it's on the top. Okay. Yes, it's on the top. Okay, good. Now, let's look at cosine. We focus also on the 5 key points. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Yes? Thank you. Yes, sorry. I forget that again. So let's go over the quiz first. Yes, sorry. Okay, so quiz. The quiz solution is on our course website. Yes. All right. So quiz 1. Solution. Okay, so that is our first problem. This is x, right? X coordinate and the y coordinates. We have x is minus 7 and the y is negative 11. So far, so good, everybody? Mm-hmm. Yeah, look at me, don't look at your phone. And then we find the r. R is square root of x squared plus y squared. So in this case, x is minus 7 and the y is minus 11. Be careful, this is parentheses. When you square a negative number, it becomes positive. So positive 49 plus 121 is square root of 170. Okay, what is exact value? Square root of 170. Just leave it like that. Do you plug in your calculator? No. Leave it like that. Don't plug in your calculator. So your sine is y over r, and your y is minus 11 over r is square root of 170. Okay, everybody? Mm-hmm. And then you figure out all the 6 trig functions. Okay, second problem. We have the triangle, the right triangle. So I said the angle and the side, they're the same letter, right? Now the opposite side use small letter, the angle use capital letters. This is how we name the angle and the vertex, okay? Here we know this side and we know this angle. So we can find the angle A. It's 90 degrees minus 81 is 9 degrees. Now you want to find the sides. This side we know. This is adjacent. And we want to find the opposite and the hypotenuse. You want to relate the unknown side and the known side. Therefore, this is opposite and this is adjacent. Which trig function? Tangent. Tangent 81 degree is opposite B over adjacent 16.5. Yes, everybody? So therefore, how do you solve for B? Both sides multiplied by 16.5. Yeah, so you get this number. Right. And then here to find C. Okay, C is the hypotenuse. And this is the known side adjacent. Which trig function adjacent hypotenuse? Cosine. So cosine 81 degree is 16.5 over C. And both sides multiplied by C. We don't want the C in the denominator. So both sides multiplied by C. And then both sides divided by cosine 81 degree. Yes, everybody? So plug in your calculator, we get 105.48. Yes, everybody? Okay. And then I want to look at the quiz mistakes. May I have your permission to print screen the mistake and go over with the whole class? May I have your permission, everybody? Okay. Thank you. So, all right. Yeah, I need. Okay, where? Oh, right here. Okay. So this is. Okay. Find the course here and the quiz mistake right here. Okay, so I click share and I have to change to everybody with the link. Okay, now it should be good. Oh, done. Okay, yes. So let's refresh again. Okay, yes, right here. Okay, so here. Oh, remember, square become positive, and your r is always greater or equal to 0. So therefore, yeah, it's positive square root of 170. Okay, and here the b is the cosine because it's adjacent over hypotenuse, so it's cosine. Okay, and yeah, so this is cosine, and then b and c. B is the opposite, c is the hypotenuse, so that is the sine. Okay, and then here, exact value. Don't use your calculator. Is that clear, everybody? In the exam, yes. Don't plug in your calculator. And here, yeah, also it should be positive. Okay, square root of a negative number. This is a complex number. In our course, we don't learn complex number. Okay, so yeah. And then here, yeah, that's the B. So sine of the angle is opposite over hypotenuse. Opposite is the B. And then here, this is correct, but the answer is wrong. So when you plug in your calculator, are you in the degree mode or radian mode? So check that. And this is sine 81 degree. And here, parentheses, okay, exact value. Don't use, don't plug in your calculator. And then when you write down the trig function, make sure you have the angle, okay? Angle is the input, so put all the theta there. And also here, okay? So yeah, not 13, don't round it, exact number. And here, draw the picture. Okay, so this one, draw the picture. Figure out the x, y, and r. Okay, and here, oh, x is the horizontal distance. So x is -7, and the y is -11. That's why it's all flipped if you get the x and y wrong. Okay, and then here, exact value. Here, let's see. Oh, exact value, don't round it. And also here is the B. Okay. Yes, B and 0. Your side cannot be negative. Your side is length, always positive. Okay, so that is quiz one mistake. So work on the practice exam over the weekend and also come to see me in my office. Okay? Have a good weekend. Joe. Come here.